This video is over lessons 17 and 18, the number line, fractions and mixed numbers, and lesson 18, average and line graphs. Go ahead and pause the video to copy down these titles. Our first concept today will require a number line. As you copy it down, just some quick reminders. Typically, in a number line, we put 0 in the middle, and then we put a tick mark for each integer. Remember that integers are counting numbers like 1, 2, 3, and so on. Their opposites, -1, -2, -3, and so on, and 0. Halfway between 0 and 1, we can put a tick mark in, and that would be 1/2. This area has now been split into 2 sections, and this is one of those sections beyond 0. So 1/2. Beyond 1, between 1 and 2, if we put another tick mark halfway in, well, again, that's a half, but we've already gone 1 full, and then we've got a half more, so this would be 1.5. On the other side of 0, the same things are happening. Halfway between 0 and -1, well, it's a distance of 1 that's been split up into 2 sections. So it'd be 1/2, but in the negative direction. And then between -2 and -1, same thing. -1.5. So what we should see here is that the negatives are a mirror image of the positives. Moving to the next slide in 3, 2, 1. This time we're going to do it again, but instead of breaking everything into halves, let's break it into thirds. So we're going to need 2 tick marks as evenly spaced between 0 and 1 as possible. So it's been split into 3 sections, so each of these is going to be a third. This first tick mark is 1 space beyond 0, and then the second tick mark is 2 spaces, so 1/3 and 2/3. Likewise, if I split the space between 1 and 2 up, this then would be 1 and 1/3, and this would be 1 and 2/3. If I go between 0 and -1 now, remember that the negatives are a mirror image of the positives. So the closest tick mark to 0 here is going to be the opposite of this closest tick mark here. So my first tick mark on the left is -1/3, and then my next is -2/3. Also notice here between 1 and 2, we had 1 and 1/3 was closer to 1. So when I split up the space between -1 and -2, just like 1 and 1/3 were closer to each other, over here, -1 and -1 and 1/3 will be closer to each other. Which means obviously this must be -1 and 2/3. Moving to the next slide in 3, 2, 1. Now we're going to go ahead and split everything up into sixths. The easiest way to do sixths, in my opinion, is to start by splitting everything up into thirds, and then take each of the thirds and split it up in half. And so we're going to use a little bit of color now. And if we go out from 0, this first is going to be 1/6, then 2/6, then 3/6, 4/6, and 5/6. But the reason I put that in red is because if I were actually labeling this, I want to reduce my fractions as I go. So down below, let's do it as we would do it properly on a number line. So 1/6 cannot be reduced, so it's just 1/6. 2/6 reduces down to 1/3. 3/6 reduces to 1/2. 4/6 reduces to 2/3. And finally, 5/6 is not reducible. And so now that I have that established, if I split the space between 1 and 2 up into 6, I should be able to do this without having to do the red. So the first tick mark would be 1 and 1/6, next be 1 and 1/3, then 1 and 1/2, next 1 and 2/3, and finally the last would be 1 and 5/6. And then if we come over here between 0 and -1, we have just the mirror image. So -1/6, -1/3, -1/2, -2/3, and -5/6. And just to finish it off, mirror image again. And it is getting a little cramped in here, so do your best. Make sure it's readable. And moving on in 3, 2, 1. Thinking about the number line can actually help us if we have a sequence involving fractions. So for example, if we had the sequence 1/16, 1/8, 3/16, 1/4, 5/16, 3/8, 7/16, 1/2, 9/16. If I were to ask you to find the next 3 numbers in the sequence, some of you would be able to tell me right away what they'd be. Others of you might struggle with that a little bit. So let's use the number line to help us. So down here, let's start actually with 0 on the left. And we'll go ahead and make a tick mark here. And this is 1/16. Next came 1/8, then 3/16, and so on. So go ahead and take a second and get this filled in. Now let's take a look here. Many of these fractions have different denominators. So the first thing that I'm going to take a look at is what would this look like if they all had the same denominator? Well, 1/16, let's just leave that. Notice that you can turn an 8 into a 16 by multiplying it by 2. So if we take 1/8 times 2/2, this becomes 2/16. Next I have 3/16. Fourths I can also turn into 16ths by multiplying by 4/4. So 1/4 times 4/4 is 4/16. 5/16 is already in sixteenths. 3/8 can be multiplied by 2 over 2, which gives me 6/16. 7/16 is already in sixteenths. 1/2, well, a 2 can be turned into a 16 by being multiplied by 8 over 8. So 1/2 times 8 over 8 is 8/16. And then we have 9/16. So if I add on the next 3 tick marks here, well, we should be able to see a pretty clear pattern of what's going on in the sequence. Each time we're going up by 1/16. So that means that my next tick mark should be 10/16, then 11/16, and then 12/16. Now before I write them in as my answer, I'm going to reduce them. So 10/16 can be divided by 2 over 2. 10 divided by 2 is 5. 16 divided by 2 is 8. So the next number in our sequence is 5/8. 11 and 16 cannot be reduced together, so that one just stays the same. And finally, 12/16 can be reduced by 4 over 4. So 4 goes into 12 3 times, and 4 goes into 16 4 times. And so the third number in my sequence would be 3/4. Moving on in 3, 2, 1. Finding an average can be a way of evening out groups. It can also be a way of finding halfway between two numbers. To find the average, we add up all of the numbers, and the answer then gives us a sum. So we're going to say the sum of all numbers, and we divide by how many numbers there were. In my class, we're going to use this setup to find averages. The benefit of setting up our averages like this is we'll have one expression that when you find the answer to that expression, it gives you the average. Moving on in 3, 2, 1. For example, let's say we had 3 stacks of books. In the first stack I had 1, 2, 3, 4, 5, 6, 7, 8 books. In the next I have 1 less, so this must be 7. And in the last I have 3. So that's 8, 7, and 3. Well, these are obviously very uneven. So what if I wanted to even them out? Well, if I find the average, that would tell me how many would be in each stack if I were to even it out. So let's go ahead and do that. So I have the sum of the 3 numbers, so I'm going to add them up, 8 plus 7 plus 3, divided by, or in this case, in a fraction over the number of numbers. Well, I've got 3 numbers here, 8, 7, and 3, so it's over 3. Simplify the numerator. 7 and 3 makes 10, plus the 8 makes 18. So this becomes 18 over 3, and then 18 divided by 3 is 6. So if I were to even these stacks out, then there would be 6 in each stack. If we look at the stacks, that should make sense. I can take 2 away from the 8, which would bring it down to 6. I can take 1 away from the 7 to bring it down to 6. And then 1 and 2 makes 3, which if we add 3 on top of 3, that would also be 6. Moving on in 3, 2, 1. There are 4 classes with 28 students, 27 students, 26 students, and 31 students. If the classes were evened out, how many students would be in each class? Well, this problem is basically asking us to find the average of the 4 classes. So, we're going to take the sum of the 4 numbers, so 28 plus 27 plus 26 plus 31, and divide the sum by how many numbers there are. Well, there were 4 classes, so there are 4 numbers I'm adding together. This requires a little bit of scratch work, so off to the side, 28 plus 27 plus 26 plus 31. We add that up. 8 and 7 makes 15, plus 6 makes 21, plus 1 makes 22. Put the 2 down, carry the other 2. 2 plus 2 plus 2 plus 2, so 4 2's is 8, plus the 3 is 11. So this becomes 112 over 4. Now this could be a mental math problem. We know that 4 goes into 100 25 times. We know that 4 goes into 12 3 times. So 25 and 3 makes 28. Think back to the problem. The problem asked me how many students would be in each class if I evened it out. So the answer is 28 students. If we even the classes out, there'd be 28 students in each class. Moving on in 3, 2, 1. What number is halfway between 27 and 81? Well, I could make a number line and start with 27 and work my way all the way up to 81, but honestly, let's not do that. It's much easier if we just find the average. So 27 plus 81, and since there are 2 numbers, we're going to divide by 2. Well, 7 and 1 makes 8, 20 and 80 makes 100, and it's still over 2. Half of 100 is 50, half of 8 is 4, and so 50 and 4 makes 54. Much easier and much faster than writing out a number line. Moving on in 3, 2, 1. The last concept of our lesson today is line graphs. And we're going to talk about the basic setup of a line graph to start with. A line graph has 2 axes, vertical and horizontal. Above the graph, it has a title. And the title will tell us what this graph is about. Along the vertical axis, we should see a label. So as we go up and down, what's really going up and down? And also, along the horizontal axis, we should see a label. Our graph now will move up and down as we move from the left to the right. We should keep in mind that in a line graph, steeper lines mean there's been more change or faster change. Moving on in 3, 2, 1. Please do not copy this chart down. You can find it on page 95. It's example 4. Here we see the title. So this line graph is telling me about Margie's height. Then the vertical label tells me that each of these numbers is height in inches, and then my horizontal label tells me that this is Margie's age in years. So I can answer a number of questions just by looking at this line graph. For example, how tall was Margie when she was 12? Take a moment and find the answer. Well, here we see 12. Follow up to the line graph, and we see a dot right there come across, and we see that Margie was 60 inches tall when she was 12. She probably turned 12 in 6th grade, which would put her about 5 feet, which is pretty close to actually the height of many of you. How old was Margie when she grew the most in a year? Take a moment to figure that out. Well, since I'm trying to figure out what year she grew the most, I'm looking for the steepest line. So the steepest line is right here. So Margie was 10 years old, or was in between her 10th and 11th birthdays. Now, try to find out how much she grew that year. Well, we can see when she was 10, she was 52 inches. When she was 11, well, she wasn't 56, but she wasn't 60, but that's a jump of 4. And we can see that this is about a fourth of the way up. So a fourth of 4 is 1. So we can go ahead and assume that this must be 57. So to go from 52 to 57, she must have grown 5 inches that year. Now try to find what year did Margie grow the least. Well, when I wanted to find how much she grew the most, I looked for the steepest line. So if I want to find out when she grew the least, I'm going to look for the least steep line, the one that's almost horizontal. And that would be right here. So it was when she was 13 years old, or between her 13th and 14th birthdays, that Margie grew the least. Lastly, would you predict that Margie will one day be 68 inches tall? Hopefully your answer is no. We can see that Margie has grown steadily, especially between these two birthdays. But as we get closer to 14, her growth is starting to level off. We can assume reasonably that she's probably going to grow very little over the next several years. Maybe she might reach 64, but 68 is just too far up there. So we would have to assume that no, she will not grow to be 68 inches tall.